US Physics Olympiad, year 2012, F equal MA, first round. Problem number 12. Solution for this problem you can find below this video in the reference of the description. A rigid hoop can rotate about the center. Two massless strings are attached to the hoop, one at A, the other at B. These strings are tied together at the center on the hoop at O, and the weight G is suspended from that point. The strings have a fixed length regardless of the tension, and the weight G is only supported by the strings. Originally OA is horizontal. Now the outer hoop will start to slowly rotate 90 degrees clockwise until OA will become vertical, while keeping the angle between the strings constant and keeping the object static. Which of the following statements about the tensions T1 and T2 in the two strings is correct? Solution. Let's redraw this picture with a mention of angles. Let's θ1 will be angle between first string and the vertical, and θ2 is the angle between second string and the vertical. Both are positive. And let's write the equations for static equilibrium in any position for these angles. In horizontal direction we have this equation: T1 sine θ1 equal T2 sine θ2, and in vertical direction we have this equation: T1 cosine θ1 plus T2 cosine θ2 equal G. Solution for these two equations are this one for T1 and this one for T2. Let's investigate them. We have in the denominator sine θ1 plus θ2, and this is constant. And this sign is also positive, because it's a lie between pi over 2 and pi. And let's check what happens if the angles are changing. T1 start from sine θ2. Initially it's increasing, and after reaching θ2 pi over 2 it starts to decrease. And for T2 we have initially sine θ1 is 1, so it means that T2 has a maximum, and finally it's reducing till 0 in position when θ1 is 0. So that's the behavior for T1 and T2. And let's check what happened to these answers. Answer A. T1 always decreasing, which is not correct. We investigated, because initially it's increasing, and after that it's decreasing. T1 always increasing. That's not correct too. T2 always increasing, which is not correct. It's always decreasing. And T2 will become 0 at the end of the rotation. That's true. In the end of rotation, sine θ1 equals 0 and T2 equals 0. And answer E, T2 first increase, then decrease, which is not true. It's always decreasing. So correct answer is D. Also, I can mention that this answer we could guess, because in the position when θ1 is 0, the equilibrium will be when tension T1 is G and tension for T2 is 0. It's just a loose position. So this is why we can guess this answer. Problem number 13. Shown below is a graph of the x component of force versus position for a mass equal 4 kg cart constrained to move in one dimension on the x-axis. At x equals 0, the cart has a velocity of negative 3 meters per second in the negative direction. Which of the following is closest to the maximum speed of the cart? Solution. Because on this graph we have force depending on displacement, we can use energy approach here. Because cart getting energy which is equal to area under the curve. And we see that positive area is till 0.6 meters, and after it's negative. It means that cart will get maximum velocity in point C, and we just need to count what is the area of this figure, this rectangle and this triangle. Let's count it. For rectangle we have 5 newtons multiplied by 1 meter, which is 5 joules, and for triangle we have 5 multiplied by 5 and divided by 2, which is 12.5. So total area will be 17.5 joules. And we need to count initial energy, which corresponding to speed 3 meters per second. So total kinetic energy equal initial kinetic energy plus work done by this force. We can mention that it doesn't matter that our body move in opposite direction initially, because it will return with the same speed in a positive direction in the same point. So, and total answer will be 35.5 joules total kinetic energy. And now we can find what is the speed in 0.6 meters. So total kinetic energy equal 35.5 joules. From here we can find what is V square. That will be 17.75, and finally speed will be 4.2 meters per second, which is answer E.